everyone. I am Rajini, working as an assistant professor in ECE department. In this video, I am going to solve some problems, gate examination problems on multiplexer. Okay, before we begin the problems, first we will briefly revise the concepts of multiplexer. Then only easily you can understand the problems. First, what is meant by multiplexer? Multiplexer is a combinational circuit. Multiplexer is a combinational circuit which select one input from any inputs and forward that one to the output. See, if you seeing this one, this is a combinational circuit. Here we are having the many inputs and we are selecting the one output. So how you are selecting that one means based on the selection line. So based on the selection line, here one input is selected to the output. So that is the main concept of multiplexer. Here there are number of multiplexers are available. Then how we are selecting one particular input. Okay, so that is based on the selection lines only. So what is the relation between the selection line and input line is 2 power n is equal to n, where n is the number of selection line and 2 power n is the input lines. Suppose if you are taking n is equal to 1, that is the selection line is 1 means the number of inputs are, that is m is equal to 2. If the selection line is 1, then number of inputs are 2. And if the selection line n is equal to 2 means, then the selection lines are 4. So like that we can design any multiple. Okay, so this is about the introduction. Now we will see the 2 by 1 marks. So for 2 by 1 marks, you are having the 2 input line and 1 selection line. So n is equal to 1 means there are 2 inputs. Okay. So this is the I0 and this one is the I1 and this is the selection line. I am considering taking this one as a S. Now we will see what is the output of this one. So here y is given by, that is when S is equal to 0, then I0 will enter into the output. When S is equal to 1 means, then I will come into the output. So this can be written as S bar into I0 plus S into I1. So when S is equal to 0, then I0 will is the output. When S is equal to 1 means I1 is the output. So this is the expression for 2 by 1 marks. Here this 2 by 1 marks can also be drawn in this manner also. So this is the I0, I1 and this is the selection line. And this one is the output. So we can represent in this manner or in this manner also. Both are same. So this is for 2 by 1 marks. So in this case the expression is S bar I0 plus S into I1. Similarly for 4 by 1 marks means so 4 by 1 marks means here there are 4 input lines, that is I0, I1, I2 and I3 and the selection lines are 2, that is S1 and S0 and only one output line. So here there are 4 inputs and 2 selection lines. So now what is the expression for this one? So this can be written as S1 bar, S0 bar into I0 plus S1 bar S0 into I1 plus S1 S0 bar into I2 plus and next one is S1 S0 I2. So this is the expression for 4 by 1 marks. Okay. So this is the basic concept of multiplexer, that is 2 by 1 marks and 4 by 1 marks. So how we are getting these values means depending upon the status of these 2 selection lines. That is 2 selection lines are there means we will get the 4 combinations, that is 0 0, 0 1, 1 0 and 1 1. Based on this one it will select the one of the input from these 4 input lines. So this is the concept about the 2 by 1 and 4 by 1 mux. Okay, now let us start the problems. So this is the first gate problem we are going to solve now. Okay, so first they have given like this, and what is the expression, Boolean expression for the given circuit. So how to solve this type of problems? Once if they have given this 2 by 1 mux means, then how to solve? So first we have to consider the truth table of 2 by 1 mux. If you see here, there are two 2 by 1 multiplexers are there, and the output of the first multiplexer, it is connected as the selection line for the second one. Okay, so here assuming that this is the E. Now how to solve this type of problems means, first we have to consider the truth table. So for the first truth table, here 2 by 1 means only one selection line is there, so that is the B value, and output is nothing but a E only. So the same E only is connected as a selection line for the second one. So B is the selection line for the first case and E is the output. So in this case, when B equal to 0, so B equal to 0 means which one will be selected? C. That is the first data line. So when B equal to 0, C will be selected, and when B equal to 1, the C bar will be selected. So this is the expression for the first one. So in this case, that E is given by B bar C plus BC bar. This is the output of the first stage. E is equal to B bar C plus BC bar. Okay, here 0 means this is nothing but a B bar, and this one is the B. So we can write B bar C plus BC bar. So this is the selection line for the second one. Okay, now we will solve the second one. Okay, in the second one, E is the selection input and Y is the output. So here also we are having the only one selection line. So the combinations are only two combinations. One is the 0 and second one is the 1. When E equal to 0, what is the output you are getting? 0, because the data is here 0, and second one is when E equal to 1, what is the data we will get? A. So A we will get it here. So finally that output expression is 0 into E bar, so that is equal to 0 plus next one is here A into E. So this is equal to A into E, and already we calculated what is the E expression, that is equal to B bar C plus BC bar. So the final expression is AB bar C plus ABC bar. So like this we have to find out the logical expression for the given circuit. So this is the final expression. So in this problem they have given the two 2 by 1 mux. So first we are calculating what is the output expression for the first stage, then that is used as a selection line for the second stage. So for that one we calculated what is the final expression. Okay, now we are moving on to the next one. So this is the second problem. So here also we have to find out what is the logical expression for the given circuit. Okay, so this is the 4 by 1 mux. This is a 4 by 1 mux means here we are having the two selection lines, that is AB, Y is the output line. So if there are two selection line means there are four combinations, that is 0 0, 0 1, 1 0 and 1 1. So first when both are 0, that is AB are 0 means, then what is the output you are getting? I0. Here that I0 value is C. So I0 value is C. And next one 0 1 means which one will be selected? I1 will be selected. So I1 is also equal to C. Next one is when A equal to 1 and B equal to 0, I2 will be selected and that value is C bar. Next AB equal to 1 means again we are getting the C bar only. Now we have to write the final expression for this one. So Y is equal to, here 0 0 means A bar, B bar, C, and next one is A bar, B, C plus A, B bar, C bar, and the last term is A, B, C bar. Okay, so this is the expression from the truth table. Now we have to simplify this one. So for that one, first, just you consider the first two terms. In that one, A bar and C are the common. So we can write it as A bar C as a common. Then we are having B bar plus B. In the third and fourth term, what are the common terms are present? A and C bar. So this is equal to B bar plus B. Okay. So already we know that the B plus B bar equal to 1. So this is can be written as A bar C plus AC bar. And it is equal to, this is the expression for XOR gate. So we can write this one as A XOR of C. So this is the final expression for the given circuit. So to solve this type of problems, first we have to consider the truth table. From this truth table, we can derive the final expression. So for this problem, the expression is A XOR of C. And move on to the third one. This is the third problem. Okay, now how to solve this one? This is also a 4 by 1 works only. We have to determine what is the Boolean function for this circuit. So in this case, if you see this diagram, here this is the connected to the ground terminal. So ground means 0 only. Here we are having that input is 0. This is the NOT gate. So at this one we will get 1. So again 1 is connected to the NOT gate. So here the value data will be 0. So I0 is equal to 0 and I1 is 1, I2 is 1 and I3 equal to 0. So like this we have to take. Now by using the truth table, that is P, Q and Y is the output. So PQ means there are two variables. So we will get the 4 combinations, that is 0, 0, 0, 1, 1, 0 and 1, 1. Okay, when both the inputs are 0, which one will be selected? I0 will be selected. So that is equal to 0. And next one is when 0, 1. PQ or 0, 1 means 1 is the output and 1, 0 means then output is equal to 1. When both the inputs are high means, that is selection lines are high means, the output is equal to 0. So from this truth table itself, we can easily find out what is the output expression. That is equal to P XOR of Q. So how we are getting? This is the XOR gate symbol. If one of the input is high, output is high. So in this case, if P is 0, Q is 1, we are getting output equal to 1. When P equal to 1 and Q equal to 0, output is 1. So this is nothing but a XOR gate truth table. So the final expression is P XOR of Q. Thank you.